this video, you are going to learn the addition, the subtraction, and the scalar multiplication of matrix. So if you are new to matrix, you basically need to first understand what a matrix is. Now, a matrix is a rectangular box, or you can call it a curly bracket that consists of elements with rows and columns. All right, it consists of elements that are written in rows and columns. So you can see in this example 1 now, we have a matrix A. And this matrix A, it's in a bracket identified by rows and columns. So this is your first row, this is your second row, all right, and this is your third row. And it also has columns. This is your first column, this is the second column. Likewise, matrix B that we have here, all right. So you also need to know how to identify a matrix. A matrix is named by the number of rows and columns that it has. So if a matrix has 2 columns and it has 3 rows, you are going to say that that is a 3 by 2 matrix. So you call the number of rows first before the number of columns. So in this case, let's consider the name of this matrix here. This is a matrix A and it has 3 rows, all right. This is the first row, the second row, and the third row, all right. And it also has 2 columns, 1 and 2. So we can say this matrix A is a 3 by 2 matrix. Why? Because it has 3 rows and 2 columns. Okay, likewise matrix B here is a 3 by 2 matrix because it has 3 rows and 2 columns. Now, in the addition and subtraction of matrix, what we are going to be doing is that we are going to be adding matrix that are of the same type. So you can only add a matrix that is of the same type to another matrix that's of that same type. All right, likewise for the subtraction operation. So we cannot add a 3 by 2 matrix to a 2 by 3 matrix. All right, we cannot add a 2 by 1 matrix to a 4 by 2 matrix. So we only add matrix and we subtract matrix that are of the same type. So let's see how to go about this first example. Now we have here that matrix A is consisting of the elements of 3, 2, 1, 3, 4, and 2. And we're adding it to a matrix B having the elements of 3, 1, 4, 5, 7, and 1. So how do we actually add this matrix? In the addition of the matrix, you have to add the elements that are in the same position in both matrix. So if you look at this element 3 here now, we are going to add it to its position of the other matrix B, all right, on this other side. So you can see that 3 here on matrix A is on the same position as this same 3 that we have here on matrix B. So we are going to add that together. Likewise, you add 2 here on this position, all right, to its respective position on the other matrix. So we do same for each and every element that we have here to have their addition or their subtraction. Now you'd want to also note that these elements that we have in this matrix have a name. For example, how do you know the name of this element? The name of this element is dependent on its position in the matrix. So what is its position actually? We consider the row and the column again to know the position or the name of that position. So this element 3 here in matrix A is on the position of row 1, column 1. So this is the first row and also the first column. So you can see that this element is on row 1, column 1. How about the name of this element that we have here? What position would we say it is? We'll consider the row and the column. So what row is it on? It's on the third row. And what column is it on? Is on the second column. So we can say this element's position here is the row 3, column 2 position. Do you understand? So we are adding each of these elements to their respective position on the matrix. So recall that this matrix is a 3 by 2 matrix. And why is it a 3 by 2 matrix? It's a 3 by 2 matrix because it has 3 rows and 2 columns. Do you understand? So now we are going to go with the addition. So here we have 3 plus 3. All right. So let's get our result. So we have 3 plus 3 and that's 6. All right, we'll move on to the second matrix. We are adding it to its respective position on the other matrix. We have 2 plus 1 here, and we have 3. All right, here we have 1 plus 4. We have 5. All right, here we have 3 plus 5. We have 8. Here we have 4 plus 7. All right, that's going to give us 11. Here we have 2 plus 1, and that's going to give us 3. So this is the simple resultant matrix. So let's call this matrix C. So in adding matrix A to matrix B, we are going to get another matrix. We'll call it matrix C, and this is the result of the addition of that matrix. Likewise, for the subtraction of matrix B from A, as asked in question 2 here, we are going to do likewise. So let's quickly solve that. right now. So we are still subtracting matrix A from matrix B. Let's write it again. We have 3, 2, we have 1, 3, we have 4, and we have 2 here. That's matrix A. Alright, and we're subtracting matrix B from it, which is having the elements of 3, 1, 4, 5, 7, and 1. So we are going to also subtract the elements that are in the same position in this matrix. So let's say our resultant matrix C this time is going to be something like this. Alright, so we have 3 minus 3, that's going to give us 0. We have 2 minus 1, that's going to give us 1. We have 1 minus 4, that's going to give us minus 3. We have 3 minus 5, that is going to give us minus 2. We have 4 minus 7, that will give us minus 3. We have 2 minus 1, and that's going to give us 1. So this is the simple subtraction of the matrix B from matrix A. So in the addition and the subtraction of matrix, this is what you simply do. You simply subtract or add the matrix that are in the same position of the number of matrices that you are adding. We can have the addition of more than 2 matrices. We can have, let's say we're given a matrix C with its elements. We can have the addition of those 3 matrices. So what we'll simply be doing is adding the elements in the same position as it occurs in all the matrices we are given, or the subtraction likewise. Do you understand? Now this is simply what you need to understand in the addition of matrix and the subtraction of matrix. Now how about the multiplication of matrix? How about multiplying a matrix A by a matrix B? Now that's what we call a matrix by matrix multiplication, but we will not be treating that right now. What we'll actually be looking at now is the scalar multiplication of matrix. So you are actually using a scalar, which is a number, to multiply a matrix, because you need to understand that first before you understand the matrix by matrix multiplication. So let's see an example on the scalar multiplication of matrix. Now in the scalar multiplication of matrix, here, given that I 2 by 2 is equals to what we have here, alright, and I 3 by 3 is equals to what we have here. Now you first need to understand that there are different types of matrix. Now I represent the identity matrix. We have the identity 2 by 2 matrix, and we have the identity 3 by 3 matrix. So I here means the identity matrix. So we have the identity 2 by 2 matrix, like I said, and the identity 3 by 3 matrix. And this matrix has a fixed representation. So the identity 2 by 2 matrix is given by having 1 in the diagonals of a 2 by 2 matrix where the other elements are 0. So let's consider this matrix 2 that we have here. You can see I'm hovering on the identity matrix 2 by 2. Alright, you can see on the diagonal here we have the elements of 1, whereas the other elements are all 0. So the identity matrix is a 2 by 2 matrix, but then on the diagonal we only have the elements of 1, while the other elements are 0. Now how about the identity 3 by 3 matrix? Here, this is a 3 by 3 matrix where we have all the elements in the diagonal of this matrix to be 1. Alright, and the other elements are all 0. So this is an identity 3 by 3 matrix. So you need to understand and know how to get this matrix, because in a question you can just be asked to find 2i. So if you don't know what I is, you might miss that question. So I is called the identity matrix. Okay, so in this question now we're given that A is equals to this matrix representation here, and we're asked to find 2i. Now let's say this I, because I didn't specify in this question what kind of matrix I is. Alright, so let's say this I here is a 2 by 2 matrix. So it simply means they want us to use 2 to multiply this identity matrix here. Okay, so this is what we call the scalar multiplication of matrix, where you are using a number to multiply a matrix. Okay, that's the scalar multiplication of matrix. So let's see how to go about question 1. So we're asked to find 2i, where I is a 2 by 2 identity matrix. Alright, so we're having something like this: 2 open bracket 1 0 0 1. That is our identity 2 by 2 matrix. So what you'll be doing is using 2 to multiply each and every of those elements that we have here, but then the result will be in this same representation format. So in the sense that we are having something like this: 2 times 1 gives us 2, 2 times 0 gives us 0, 2 times 0 gives us 0, alright, 2 times 1 gives us 1. This is the result of 2i. So you are actually using 2 to multiply each and every element in their respective position to give you a resultant matrix that is in the similitude of this matrix type, which is a 2 by 2 matrix. So you can see our result is also a 2 by 2 matrix. Why? Because we have 2 rows and 2 columns. You understand? Now let's consider the second question that asked us to solve for 3a. Alright, so we have the scalar there to be 3, and we are using matrix A to multiply that scalar. So we are having this in question 2, 3A. So we are having 3 times what's A? A is the element of 2, contains the elements of 2, 4, 1, and 1. So we are going to do likewise here. We are going to use this scalar of 3 to multiply each and every element in the matrix, so that our result will still carry the format of this matrix. So we have 3 times 2, and that's giving us 6. We have 3 times 4, that's giving us 12. We have 3 times 1, that's giving us 3. 3 times 1 gives us 3. So this is simply the result of the multiplication of this matrix. So this is what we call the scalar multiplication of matrix. And remember that it's called the scalar multiplication of matrix because we are using a scalar number, all right, to multiply a matrix. So in the next video, I'll be showing you how to actually solve a matrix by matrix multiplication. So you'll be seeing that in the next video. If you would like to see more explanations on other math topics, click on the subscribe button and also hit the notification bell icon to be notified when I make another video. Also check the link in the description to get access to helpful math textbook on my Telegram channel right now.